In this video, we're going to look at how we can show that a sequence is decreasing when we're given its recursive form. So let's look at the question. We've got the sequence of numbers u1, u2, u3, and so on, and it's n same as greater than 1, because you can see our first term position is positive 1. And we're told that un is greater than 4 for all those values of n. Okay, so what that means is the value of every term is greater than 4. That's what that inequality is telling us. Then we're given the recurrence relation here, which looks pretty complicated. It's in the form of a fraction. So we've got un plus 1, and on the right-hand side, we've got a lot of un terms there. And we need to show that un is decreasing for n same as greater than 1. So essentially for all terms in the sequence. Now, if a sequence is decreasing, that means we can take any term in the sequence, and it is going to be smaller than the previous term in the sequence. So n plus 1 for any term, and the previous term would then therefore be un. So we need to prove that this inequality is true for all values of n. First thing I'm going to do is rearrange this inequality. So I'm going to subtract the un to the other side. So I get un plus 1, subtract un, must be smaller than 0. So for the top inequality to be true, the bottom one must be true. So I'm going to focus on trying to prove this bottom one. I'm going to try and show that if we do un plus 1, subtract un, it's definitely going to be smaller than 0. In other words, the difference between any two terms is smaller than 0 when you take any term and subtract the previous one. Now, in order to get this process started, I can't start by writing smaller than 0. Okay, I need to prove it. So I need to start by playing around with the un plus 1, subtract un. And what I need to think about is, what could I potentially replace these with, if anything? So if we look at the un plus 1, well, in the recurrence relation we're given, we're told that un plus 1 is equal to this fraction over here. So what I'm going to do is replace the un plus 1 with that fraction there. So I'm going to write un squared plus un plus 12 divided by 2un. And then when it comes to the subtract un, I'm actually going to leave it as it is for now, because I like how on the right-hand side, the only subscript terms I now have are uns. Okay, so let's play around with this. What I want to do is try and combine this into one single term. So I'm going to write the un as a fraction. I'm going to write it as un over 1. So I'd get the same initial fraction, and that's over 2un. And then I'm going to write subtract un over 1 like that. Now, to subtract these, I need a common denominator. Okay, so we got 2un here. So if I multiply the 1 by 2un and multiply the numerator by 2un, I'm going to get my equivalent fraction with common denominator. So the first fraction is still unchanged. And then my second fraction is going to be un times 2un. So that's going to be 2un squared divided by our common denominator of 2un like that. So we can now subtract our numerators. Our denominator will stay exactly the same. And we're going to have un squared subtract 2un squared. So that's going to give me negative un squared. And then the rest of my terms are going to stay the same. So we'd have the plus un and then the plus 12 like that. So now we've got it written as a single fraction. I need to show this fraction is going to be smaller than 0. Okay, that's my goal. So to do that, I'm going to go and factorize my numerator. So I'm going to start by factorizing out the negative 1. I don't like the fact that that's in front of the un squared. So I have negative 1, open brackets, un squared, and it'd be subtract un, subtract 12 like that, and then divided by 2un. And then let's go inside my bracket and factorize. Well, I've now got 1 un squared in there. So it's going to be double brackets, and it's going to be un times un. And then we're looking for factors of negative 12 that add to negative 1. So that would be negative 4 and positive 3, I believe. And that's all divided by 2un. So remember, this expression here, this fraction is equal to un plus 1, subtract un. And I need to explain why this is always going to be smaller than 0. So let's start with the denominator, given there's not too much going on there. So we've got 2un. But if we look back at the start of the initial question, we're told that un is greater than 4 for all values of n. So if we go back down here, we know that un is greater than 4. Now we're considering 2un, so I need to multiply by 2 on both sides of my inequality to get 2un is greater than 8, which is of course greater than 0, given that we're thinking about positive and negatives here compared to 0. So what we can conclude is that 2un, our denominator, must be greater than 0. Okay, it's always positive for all values of n. So I'm going to write for n same as greater than 1. Now let's consider my numerator. So for the first bracket I've got here, the un subtract 4, well, we know that un is greater than 4, as that's what was given in the initial question. I want un subtract 4, so I'm going to subtract 4 from both sides to get un subtract 4 is greater than 0. Okay, so that must be the case for n same as greater than 1. So I know that that bracket is always positive. Now let's consider my other bracket in my numerator. So we know that un is greater than 4 for all values of n. We want un plus 3, so I'm going to add 3 to both sides. So I get un plus 3, and that will be greater than 7 when I add 3 to the other side, which is of course greater than 0. So I can conclude that my bracket un plus 3 is greater than 0 for n same as greater than 1. So now let's consider our multiplication of our brackets in our numerator. Okay, we can say therefore, since the un subtract 4 is always greater than 0, and the un plus 3 is always greater than 0, then the product of those two must also be greater than 0 for n same as greater than 1. But remember, our numerator is also multiplied by -1, so what I need to do is multiply this inequality by -1 on both sides. So I would get, therefore, negative un subtract 4 times un plus 3 must be smaller than 0, because we need to flip the inequality to be multiplied by negative for n same as greater than 1. So we've concluded our numerator is always going to be smaller than 0, whereas our denominator, we concluded, was always going to be greater than 0. So if we've got a number that's smaller than 0, so negative, divided by a number greater than 0, which is positive, then our whole fraction is going to have to be negative for all values of n. So we can say, therefore, our fraction, okay, which is the negative un subtract 4 multiplied by un plus 3 over 2un, must be smaller than 0 for n same as greater than 1. And remember, this fraction is equal to the un plus 1, take away un, so I can say, therefore, un plus 1, take away un, must be smaller than 0 for n same as greater than 1. So what I can then do is rearrange that inequality, so I can say un plus 1 is smaller than un for n same as greater than 1. And then we can say, therefore, the sequence un is decreasing, because what I've established is that if you take any term in our sequence, it is going to be smaller than the previous term. So that is your complete proof.